Great. Okay. Well, a very, very good evening to you. My name is Sean Fitzgerald. I'm the director of the Centre for Climate Repair here at the University of Cambridge, and it's great to be able to welcome you to this event on climate intervention, a distraction or a necessity. So it is my absolute pleasure and privilege to be able to introduce you to our panellists this evening. So we're going to be in the capable hands, first of all, led by Oliver Morton. Oliver is the Economist's senior and briefings editor. Before joining the Economist, he was the chief news and features editor of Nature, the international scientific journal. He specialises in the energy business, climate science and policy, and other green issues. He's the author of Eating the Sun, How Plants Power the Planet, and Mapping Mars, Science, Imagination and the Birth of a World. We will be then followed by my very dear colleague, the Deputy Director, Professor Hugh Hunt. He's the Deputy Director of the Centre for Climate Repair and he's a Professor of Mechanical Engineering in the Department of Engineering. He was part of the SPICE project, which looked into stratospheric aerosol injection and has featured in multiple documentaries, including Dam Busters, Bouncing the Bomb on Channel 4. And I would recommend that you go and find that on YouTube. They're a lot of fun. We are then going to be entertained by Alicia Fredrickson, who is the co-founder of Seabound, a company specialising in carbon capture for ship owners to help reduce their emissions. She helped build the leading maritime electro-fuel startup Liquid Wind and launched a climate programme at Generation, a global not-profit company founded by McKinsey & Company. And then finally, we will be listening attentively to Robert Criss, who is an independent researcher with his research centering on the emergence of complexity thinking in the then nascent geoengineering discourse. He's the author of Systems Thinking for Geoengineering Policy, the Paris Agreement, Implications for Greenhouse Gas Removal and Zero Emissions Energy Production, and also co-authored an article entitled, and incredibly pertinent for this evening, Moral Hazard or Moral Duty, Repairing the Climate with Greenhouse Gas Removal and Solar Radiation Management. So could I first of all welcome Oliver to kick us off for this evening, and then we'll bring other members on at the end when we have questions. Oliver, okay. Over to you.
Thank you very much indeed. And it's lovely to be in the Babbage Theatre again. I was asked to quickly run through what we're talking about and give a very small part of my own perspective. My own perspective is that Andrew Lockley is late. But other than that, live captions, no, I don't want that. I want that. Next slide, there we are. Is that right? Yes, good. So yes, I should say I'm a senior editor at The Economist, as Sean so kindly said. I'm also the chair of the trustees of the Degrees Initiative, which I will talk a little more about next, so at the end of this discussion. So as I always try and say when I'm talking about this, but especially when I'm talking about this in Cambridge, we must remember that climate intervention, or geoengineering, or whatever you might wish to call it, is Promethean science. And Simon Schaffer, the great historian of science who used to work just over there in the HBS department on Free School Lane, defined Promethean science like this: an experimental enterprise that mixes a vaulting ambition to safeguard humanity against a major threat with the troubling hazards of following this science's recipes. And as some of you may remember from previous talks, the Promethean science that Simon was actually coining this term for was the science of lightning rods in the 18th century. When vaulting ambition was basically something that we might hear about in these discussions, playing God by saying where the lightning should come from. Prometheus here was, in Goethe's phrase, was Goethe's way of referring to Benjamin Franklin for thinking he could pull down gods, and of course, at the same time, importantly, thinking he could pull down kings. Vaulting ambition to safeguard humanity against a major threat, troubling hazards of following this science's recipes. That seems to me, has seemed to me for a long time and continues to seem to me a crucial way of understanding all our discussions about climate intervention, geoengineering and the like. So, climate intervention comes in a number of forms. carbon removal, sunlight reflection, and specific physical interventions that don't really fit. So I would say sort of like somewhere between glaciers and grab bag, you will find these other interventions. I'm just going to run through them very quickly. Here is carbon removal, which we'll be hearing more about from Alicia. The thing to notice about this diagram is that there are lots of options. There are lots of different things you can do. And here are the descriptions of them. And so I'm not going to read through them all, but you have industrial things like direct air carbon capture and storage. You have afforestation, reforestation, soil management, and off at the right-hand side, stage left, you have ocean fertilization. And the thing that's important to remember here is that these all have the same effects. These all take carbon dioxide out of the atmosphere. They have regional effects because of the regions where they're used, but in terms of their climatic effects, they all basically work out the same because carbon dioxide is a well-mixed gas in the atmosphere. Take it out from one place and you are effectively lowering or slowing the increase of the global average. But they operate on very different scales. The amount that you can do with minerals for enhanced weathering is effectively potentially near infinite. The amount you can do with biochar isn't. And their benefits, as is shown rather nicely on this chart, are different in the length of time that they last you. Some of these things, what our friend Miles Allen, who spoke at one of these events last year or the year before, would say geological storage is the way to go, but there are also people who want to store things in vegetation, in sediments, and indeed in the built environment. And all these things can be valid options, but you have to remember the time scale when you're looking at these different things. So there's carbon removal in 2 minutes. Here is sunlight reflection. This diagram, which I haven't quite put the attribution properly, but it's SRM 360, which is a nice new NGO. I'm on its advisory board, which is putting out information about what it likes to call sunlight reflection methods, and I tell it to call solar geoengineering. And this is one of various infographics and other briefing materials that you can find on their site. So that's srm360.org. And here you see the things that some of us already know about. You have, over on the left, you have a plane spreading something into the stratosphere. Over on the right, you have a plane messing with some cirrus clouds. Right in the middle, you have some mirrors in orbit or at a Lagrangian point. This is not a near-term option. Down the bottom left, you have some marine cloud brightening, which is also what you have on the delightful pixelated thing at the top. And if anyone can animate that with a sort of like 16-bit music thing, that would be very pleasant. I would like that very much, to have it running across. So little project for any coders who get bored during this. And in the middle you have, you also have changing the surface albedo. They've chosen in this diagram to make it the surface albedo of a city, but it might be, and it's even possible someone might mention this later, it might be the surface albedo of, say, somewhere in the Arctic. Interesting thing to remember about this is that these are not all interchangeable in the way that I said that carbon dioxide removal was. Space mirrors and potentially stratospheric aerosols are global in effect. Marine cloud brightening, surface brightening, and cirrus stuff, that's all regional. And so you do have very different sorts of impacts from those different approaches to geoengineering. Now, and the last one, specific physical interventions. Here's one that, again, we might hear about later, and we certainly would if John Moore was here, which is the idea that you can stop warm water from eating away at the bottom of ice sheets that are floating on the sea. And the idea here is that if you put up one of these barrier thingies, the hot water will, the warm, let's be fair, this is in the Antarctic, it ain't hot, but the warm water will be kept away from the glacier front, and the glacier front will thus not be eroded back, and the ice stream on top of the glacier will not destabilize, and the sea level around the world will be saved from being risen. God, that was an ugly sentence. Sea levels will not rise as much. Thank you. And there are other things here, and I think it's interesting that we don't talk about these very much, but there are various sorts of physical interventions that are possible. You could think about, although they're also talked about in terms of fertilization, you can just talk about bringing up cooler seawater to the surface ahead of a hurricane. Might be something that you might do to change the environment. You might think about, in fact, people used to think about quite a lot about ocean current modification. Don't think anyone does now, not sure that we miss it, but I thought I'd put it on here for completeness. And here's an interesting one that I think we might see a bit more of. Massive continental hydrostructures. This is Nevada and the dark blue is the Ice Age lake coverage of Nevada. If you have unlimited energy, you could pump water back upwards to Nevada to fill in some of these lakes and thus radically change the climate across much, but not all, of the southwestern United States. This is an idea that would have been completely ludicrous until solar power became ludicrously cheap. Now it's just ludicrous, not completely ludicrous. But these sorts of ideas, I think we'll probably not get on too much tonight, but I think that it's important to, for a certain amount of sort of like conceptual honesty, to remember that although we tend to talk about solar geoengineering, SRM, and carbon dioxide removal, they aren't the only ways of messing with the Earth system, and we should, I think, keep that in mind. So, is this a distraction? This is a global surface temperature record. These are all the different data sets. They all agree that last year was over 1.5. People say that's not really being over 1.5. You have to be over 1.5 for a certain average period of time. I think that if you don't think that this curve is going to start behaving a different way, you can be pretty sure that sometime around the time you first go over 1.5 is around the time that you are, on average, going to have gone over 1.5. I'm not a mathematician, but that seems the way to bet to me. It's also possible, as Jim Hansen has been arguing, that we are, in fact, speeding up. In fact, to be fair, all climate models say that warming should be speeding up for the reasons that Jim gives, which are that there are fewer aerosols in the atmosphere because industrial processes are putting less aerosol back up into the atmosphere. And so here we have Jim's idea of truly accelerated warming, but even without that level of acceleration, this still looks bad. Here is CO2 emissions. It's bad again. It's not quite as terrible as it was in the 2000s because China can't burn all that coal again, but it is still pretty disturbing. And you might think, yes, but now we have, now we have the same slide again because I can't use slide sorter. But now we have, and we do have, amazing renewable technologies. And I am second to no one except possibly my friend Hal Hodson in understanding the extraordinary power of the exponential growth of solar photovoltaics. This is actually installed capacity. It is an incredible thing. We wrote in The Economist in sort of like 2005 saying, yes, it's growing exponentially, but that won't matter for decades, as though decades don't happen. And guess what? It's happened for decades, and yeah, it's really extraordinary. And, the next doubling of solar photovoltaics will happen by the end of this decade, probably well before. And that doesn't solve the climate problem, but it certainly gives you some tools. The problem is, here's the same data, actually slightly different. This is actually electricity production, not electricity capacity. Here you see that solar, yeah, it's growing, and wind's growing, but, they're still not noticeably different from hydropower. We've had hydropower for 150 years or so, and, they're still, they're not yet at that level, but they are growing quickly. So you might think, well, yeah, still, it's going to be good. But here's this chart, that's the same chart down there that we just had, And here's a different way of representing it up at the top right. You'll notice that little thing at the top, I don't have a pointy thing, but I'm sure you can see it. Up at the top right corner, there's a little bit of scriff as things seem to be peeling away like a dog-eared page. That's the renewables revolution. As you'll notice, most of the rest of the picture is still oil, coal, natural gas, and to some extent traditional biomass, which is an issue all of its own. That's the context. When you look at the temperature changes and you look at that, you have to think, really? Distraction? There it is without... It's a small thing. It's a big thing by any human standards. It's a small thing by the standards of what we're continuing to do to the planet. And I know that it will grow bigger. And I know, as I just said, that after a few decades, exponential growth really, really begins to mess with your mind. But right now, when we're already more or less at 1.5, you have to think that that's a fairly sobering diagram. So, should not be news to anyone, but decarbonisation is hard. Yes, talking about carbon dioxide removal and solar geoengineering may make decarbonisation harder. That's the moral hazard problem that we're going to hear about later. And so, yeah, maybe that is a distraction. I certainly think that a world with significant amounts of solar geoengineering is probably going to decarbonise more slowly. I think it's very unlikely that that would not be the case. But is it a distraction from something that's, really good and really getting somewhere and really doing the business? No, it's not. It's a distraction from something that is itself not yet working far enough, and which, if we look at the world around us, I think it's hard to argue that the really good times, politically speaking at least, for reducing emissions are just around the corner. I think we may have had the political will that we're going to have in many places for this. Doesn't mean that it's a council of hopelessness. I think that the technology, as I said, very, very cheap, non-emitting technologies are definitely going to make a difference. But still, if you're being distracted if you think this is a distraction, you need to think, well, what would happen if we weren't distracted? Would it really all be okay? Next, necessity. I'm really cagey about terms like necessity. I flinched when I saw it on the title of this. I thought about being snarky about it, but I thought then that, well, actually, I reserve the right to be snarky about it later if I get moody. But for now, I just wanted to say necessity for whom? Who is it necessary for? Who gets to say that something is or isn't necessary? It's a decision that people need to make for themselves, and this is where the plug for my organisation, or rather the organisation I have the honour to be the chair of the trustees of, this is the Degrees Initiative. The Degrees Initiative exists to make it possible for more people and more polities around the world to have an informed voice and information they can trust about solar geoengineering. This is our mission. We are changing the global environment by making sure that developing countries can do solar geoengineering research, have bodies of expertise within them that can assess geoengineering research, have trusted scientists in the country who policymakers can turn to for advice on solar geoengineering research. And, hello, go on, there you are. And a little measure of our success is that this is what the global solar geoengineering map looked like in 2018. As you'll notice, there's nothing south of the equator, and there's nothing in Africa or Latin America. And here's where we are now. These are the countries where we have funded physical science research, social science research, often both. Later this year, we'll be holding our first annual forum in South Africa to bring together solar geoengineering researchers, policymakers, advocates, and critics from around the world. And we'll be able to do that welcoming dozens, probably well over 100 solar geoengineering researchers from developing countries who would not be there had we not been able to give them the grant money that we've given them. So that's what we do at Degrees. We help people we give people the wherewithal to work out whether it feels like a necessity for them. What might make it a necessity? Why might it not be a necessity? So that's my spiel, and hello, Go on. Okay, I don't seem to be able to get the next. Ah, there we are. There we are. And now we have Hugh Hunt, who's going to tell us about that notion of necessity. And I will not be snarky and make any rude comments.
Thanks, Oliver. So I'm part of the Centre for Climate Repair here in Cambridge, and I want to just give you a bit of a perspective of where I come from as to why I feel it's a necessity. The thing that we're very interested in our Centre for Climate Repair is how we deal with the Arctic. And why is the Arctic important? It's important because the Arctic, if you think of the whole of the Earth, yes, we know that we've got 1.5 degrees average warming, but up in the Arctic, it's 3, perhaps 4 times warmer there. And the Arctic melting, well, what are the effects? Well, the first thing is that whiteness is reflective. And ice in the Arctic reflects sunlight and helps to keep the Arctic cool. The ice melting means that it yields to open ocean, which is much less reflective, and it's reckoned that the reflectivity drops from about 0.6 to 0.1. And we also know that under the Arctic is methane, and as the ice melts, the methane is released, the methane that's locked up in the permafrost, and methane is a very potent greenhouse gas. And we also know that floating sea ice melting isn't responsible for sea level rise. You might have done that experiment with a glass of water with ice in it, which is on the verge of overflowing. The ice melts and the water doesn't overflow. But land ice, the Greenland ice shelf, will melt and cause sea level rise. Perhaps there's 7 meters locked up in Greenland, and another 50 meters of sea level rise locked up in the Antarctic, were we to get that far. And that sea level rise causes flooding, and there are some Pacific islands which will be lost completely. So flooding isn't, as my colleague Sean would say, it's not just about losing a beach or two, if you might mean losing a few nations. And we have seen how wacky the weather has become because of the warming Arctic. Now, when we're thinking about the warming Arctic and the ice vanishing, at what point in time do we say, imagine this is your gin and tonic or whatever it might be, at what point in time do you say, hey, can I have some more ice, please? And visualizing when we might need to act, I think it's quite important, having an idea. You know, I would say, yeah, now would be good to have some more ice. You know, that was 4 years ago. Things are getting worse fast. And, well, what are we going to do about it? If in 100 years' time my great-grandchildren say, hey, why didn't they do anything? They're not going to mind whether it happened in 2028 or 2035 or 2042. Pretty sure the Arctic we're going to lose the Arctic unless we do something about it. Now, John Shepherd, sadly, I never met him, but he died a while ago.
John's not dead. Just point of information, John's not dead. He's happily living in Snape.
Well, that's news to me. Really?
Yeah.
Oh, sorry, John. Can we edit that up? Oh, really? Okay. Fine. Well, that's a bit embarrassing. Oh, well, John. Okay. Well, so John famously wrote at a conference this thing which has become known as the napkin diagram, and I've got a napkin here, and I drew it out. The napkin diagram, funny, if you Google napkin diagram, this is what you get. You know, you get this thing about geoengineering. Napkin diagram says that temperature on the left-hand side, time on the horizontal axis, business as usual, BAU, things are going to get pretty bad pretty quick. Emissions reductions alone, as Oliver was saying, is not going to happen quickly. Carbon dioxide removal, you know, again, that's going to take a bit of time to get going, but we're going to need to do it. But whatever happens, we're left with this hump, this overshoot, as it's called, where we want to be able to do something like solar radiation management to keep the temperatures down. Emissions reductions alone is not enough. Now, I was involved in this SPICE project, as Sean said, stratospheric particle injection for climate engineering, where we learnt from 1991 Mount Pinatubo erupted in the Philippines and caused a degree of cooling or thereabouts for a year or thereabouts. Could we imitate that in some way? And so our SPICE project was looking at how we might use a tethered balloon perhaps to put some stuff into the stratosphere to imitate the active effect of the volcano. This diagram's not to scale, but it's just to illustrate that you might want to do this somewhere in the sort of equatorial regions, and this would reflect sunlight. Now, all well and good, the technology, very interesting technologies to research and to explore, but one of the issues is that when you come to do these things, people get all sort of annoyed that we're even thinking at all about doing geoengineering. There is this, is it a distraction? And just last week, I think it was in The Guardian, there was an article about UK funding of geoengineering, and that it was a bad thing. Geoengineering should not be funded because it's a distraction. And in my view, it is unfortunate that the research is not being done, because at some point in time, were we to need geoengineering, then I'd like to think that it was researched. One of the things that bothered me, though, was in this, you like to think new scientists would get the science right. Which direction do you reckon the wind is blowing in this diagram? Well, you know, they decided that they needed some more space. So I feel that it is a necessity, and it's not a distraction, and I take on board absolutely the very well-made point from Oliver that necessity needs to be nuanced with the for whom, but I'm still happy to go with the necessity. Thank you very much. And over to Alicia.
Okay. Okay, cool. We will get into a video in a second. But before we do so, thank you so much for having me. So I'm Alicia Fredrickson, co-founder and CEO at Seabound. We're a startup focused on decarbonization, and we do carbon capture on ships. But I think there are potential parallels or learnings or collaborations that we could do more focused on geoengineering down the line. So I'll start with giving you a little bit of an introduction to what we do at Seabound. This is from our first pilot project where we captured CO2 on a container ship. And then I'll tell you a little bit more about how we may or may not relate to the world of geoengineering. We probably won't watch the whole thing for the sake of time, but we'll do a couple of minutes.
Seabound is a climate tech startup based in London that's on a mission to decarbonize the shipping industry. We build carbon capture equipment specifically for ships to trap the CO2 in the exhaust that's coming out of their engines. The shipping industry is one of the very last sectors that has yet to figure out how to reduce its CO2 emissions, and it currently accounts for about 3% of global CO2. If shipping were a country, it would actually be the 6th largest emitter in the world, so I recognize that we could have a really massive impact by decarbonizing shipping. Shipping is extremely hard to decarbonize because you need huge amounts of energy to transport large volumes of goods over long distances. This is an urgent challenge for ship owners today because there's brand new global regulations that require all ships to reduce their CO2 emissions.
So we hook our system into the exhaust of the ship right before it would normally go into the atmosphere. Instead, it goes through our system. We bring the exhaust gas into contact with calcium oxide. That reacts at a pretty high temperature with the carbon dioxide in the exhaust gas and stores it in a solid form as calcium carbonate, which is limestone. And up to 95% of the carbon dioxide that's in the engine's exhaust can be reacted and stored as calcium carbonate, and then the cleaned exhaust goes into the atmosphere.
We then store the limestone on board the ship, bring it back to port, and then either we can sell the limestone to be used as a building material, or we could separate the limestone back into quicklime and pure CO2, to then reuse the quicklime to capture more CO2 on another ship, and sell the pure CO2 to make new products such as electrofuel or to be sequestered underground. We're racing to tackle the climate crisis.
Okay, I think I'll leave it there. Hopefully that gives you a bit of a feel.
Seabound is a climate.
Cool. So that's a very brief introduction to Seabound. So we are in that first category, I suppose, of emissions reductions and focused on decarbonization. And as you've seen, right, we basically trap the CO2 in the exhaust gas coming out of the engine, and we turn it into limestone. We have a containerized system. It's basically a box of rocks. So it's pretty simple to explain to our ship owner customers. But it's an example of how this industry, which is one of the last hard-to-abate sectors, it's trying to get clean fuels. They are looking at mechanical sails now. But it's really, really hard to reduce emissions from ships, and that's why we basically keep them burning conventional fuels but trap the CO2. So there is potentially a world in which we could use our technology, pair it with something like biofuels, and actually then have a carbon removal system, which gets us into that second category. But I think that the shipping industry is also potentially an interesting collaborator or partner when it comes to things like climate intervention as well. So just to kind of illustrate it very clearly, right? But we have ships traveling all over the world. There's about 60,000 commercial ships in the world today. There is one global regulator, which is the International Maritime Organization. And so when we're thinking about opportunities or requirements to do climate interventions that could have a global impact, having a global regulator, I think, is really helpful to be able to collaborate and potentially look at, well, are there any policies or are there any research programs that we could do and roll out more quickly? You also have some really, really big players in the industry, so like Maersk or MSC, big shipping companies you might have heard of, that are very active in catalyzing decarbonization, and I could imagine might be interested in participating in at least research projects, if not trials or deployment as well. So we have kind of some ingredients, I think, for impactful projects. We also have an interesting case study, and I think others on the panel might be able to tell you even more about this. But essentially, in 2020, the IMO implemented a new regulation to reduce sulfur emissions from the shipping industry, because sulfur is really harmful for human health. And so essentially, ship owners had two choices. They could either pay for more expensive, lower sulfur content marine oil, or they could install something called a scrubber on the ship to basically capture the sulfur content in the fuel that they were burning. And if you installed a scrubber, you would eventually save money, depending on the difference in the fuel price, but you would eventually save money because you were burning a cheaper type of fuel. So this was adopted globally because the IMO said you had to do this in order to operate your ships, and because ship owners could save money if they were burning a cheaper type of fuel. And so it was rolled out very significantly. The challenge is that sulfur reflects solar radiation, and so I'm seeing some nodding heads, right? So you might have read about this, that the IMO accidentally contributed to geoengineering because now we didn't have that cooling effect anymore. And so I think given that we're already playing with the Earth's systems accidentally, I think it's a necessity to at least research what we're doing today and whether or not there's any other opportunities to better do that. Maybe we could change the IMO regulation. And I think to me that's just one example of potentially a low-hanging fruit opportunity to try to get involved in sort of maybe reducing the type of geoengineering that we're already doing today. And so I guess my sort of closing vision, if you will, is that the shipping industry could potentially be not one of the hard-to-abate sectors in a few years or maybe a decade. It's not just heavily polluting, it's not just a dirty industry, but could it actually be a facilitator or maybe even a catalyst for climate solutions? Whether that's using the 60,000 ships around the world purely for data collection from the ocean or for the atmosphere initially, but then maybe for running trials and eventually deploying new types of solutions as well. So I'll leave it there for now, and that's my little team.
That button there. Okay, I don't really want that on yet. So How do I? Well, I'm just going to leave this. I'm going to leave it up because I've only got 2 slides. I was a late arrival at this ball, so you have the good fortune to know that I haven't had a chance to prepare many slides. So anyway, climate intervention, distraction or necessity is a really interesting question. I'm going to approach this from the perspective of risk, because the view is that climate intervention is supposed to confer some benefits on us, and if those benefits are important to us, then we have to ask ourselves, how likely is it that those benefits could be secured without climate intervention? And if we decide that it's sufficiently likely, then clearly climate intervention is a distraction. Otherwise, it's a necessity. So that's the kind of simple decision cycle we're going to look at. So let's start by just being clear about what we're talking about here. We've been doing climate intervention for centuries, indeed for millennia. So in truth, whether it's a distraction or a necessity, it's already certainly a fact, and possibly the question here should be more about whether we should do our climate intervention more rationally, and if so, how we might do it. But there are climate interventions and climate interventions, as has already been made clear. And what we've been doing so far has been inadvertent and unstructured. What this question is about is doing the interventions purposefully to reduce the risks from climate change. Now, this is really more of a climate management than it is intervention. So climate management here is the large-scale intervention in the climate system, although not necessarily in the atmosphere, to change the climate, but it doesn't include behavioural change. So things, for example, consuming less, flying less, becoming a vegetarian, switching to renewables. These are all behavioural changes. They do have climate impacts, but they're not the sort of climate interventions that we're really discussing here. On the other hand, fertilising large areas of the ocean, these are all examples that were on Oliver's slide earlier, to increase or efforts to significantly increase the marine biomass, machines to suck out vast amounts of carbon dioxide from the atmosphere and permanently sequester it, or indeed to oxidize methane in the atmosphere, and indeed anything that's done at scale to alter the reflectivity of the planet. These are examples of the climate interventions, the climate management that is under discussion here. Now, I said we're going to look at this from a risk perspective. What do I mean by risk? Well, risk is a kind of a word that's kind of used a lot. Actually, I did a little search on the last IPCC assessment reports, and in the 3 reports, in total, the word risk is used over 16,000 times. I thought that was quite extraordinary. But it is often used, and indeed even in the IPCC reports, it's often used simply as a kind of a synonym for likelihood, the risk of something happening. But it actually, in policy making, where it's necessary to prioritize, the risks have to be measured. And in that circumstance, the standard practice is to make risk a function of the likelihood of something undesirable happening and the potential harms if it did happen. So if I walk around barefoot, it's almost certain that sooner or later I'm going to stub my toe. Okay? Very high likelihood, very low harm. Nobody's going to get too worried about that. But what if the harm is Kokorki and mass extinctions through the biosphere? Oh, Kokorki, I need to make that clear. Kokorki is my acronym for the collapse of civilization as we know it. And when you look through the IPCC reports and other materials, once the warming, post-industrial warming gets to 2.5, 3 degrees and more, we are definitely in Kokorki territory. Bad things begin to happen very rapidly, and they spread very fast, and they would be, by the time that was in train, it would be very difficult, if not completely impossible, to stop them from happening. The sheer scale and energy in the climate system is enormous in relation to human capacity. So you might consider that those sorts of risk, Kokorki risk, is serious enough to be worried about and to do something about. So let's talk about that. If it's that big a deal, you'd presumably want the likelihood of it happening to be vanishingly small. To be vanishingly small. So how likely is Kokorki? Well, I first just need to take a little detour to give you a 1-minute lecture on climate change. Here it goes. The Earth is warmed when sunlight strikes any surface in the atmosphere, on land, in the ocean, and is transformed into heat. About 30% of the energy coming in from the sun is immediately reflected back into space before it warms anything, before it's transferred to heat, and that 30% is known as the Earth's reflectivity, or its albedo. The Earth cools by the passage of infrared radiation back out to space. The infrared radiation is radiated from the Earth's surface, and it goes back out to space. So if the net energy coming in from the sun is more than the energy going out in the form of infrared radiation, the Earth will warm. And when that happens, the infrared radiation that escapes is pushed to a higher altitude. It escapes from a higher altitude where it's colder and the process is less efficient. So the basic physics is that the lower areas will warm more to radiate more, and gradually the system will be brought into equilibrium. And when that happens, of course, the surface will be warmer than it had been before. And to give you kind of an example of where this really has happened in spades, just think about Venus. On Venus, the surface temperature is about 460 degrees centigrade. Now that's partly because it's closer to the sun, but it's mostly because its atmosphere is over 90% carbon dioxide. So you've got this massive greenhouse effect. So in summary, the Earth gets hotter when there's less sunlight being reflected back to space. And it also gets hotter when there are increases in greenhouse gases that make the escape of infrared radiation less efficient. So if you want to sort out global warming, you've only got two choices. You've either got to make the Earth's albedo, its reflectivity, greater to reflect more of the energy from the sun, or you've got to reduce the greenhouse gases in the atmosphere to make the process whereby the infrared radiation escapes more efficient. Any process, any action designed to combat global warming has to do one or other of those things. And all of the examples that Oliver put up do indeed do one or other of those things. And of course you could do a combination of both. It's not an either or, and that's also quite important, that it's not an either or. So the question we're really confronted with, do we need, how, if we're concerned about this risk of Kokorki, do the existing measures make it vanishingly small? So here I come to my slide. So what do? I do that, and we get that slide. Perfect, right. So this slide is from it's from the second working group, a report from the IPCC 2020-2021. And it's very simple. You've got the timeline across the bottom, you've got the temperature increase warming on the left, and the lines are the examples of from 5 of the different emission scenarios that they use to illustrate what's going on. The little break here in the middle, where you have the black line on the left, that's historical observational data, and then the coloured lines are the projections for the future. Okay? So you can see that there's only 2 lines at the bottom here that look, they're going to save us from Kokorki, right? All of the other 3 are problems. But actually it's worse than this. It's worse than this, because this chart that was published 4 years ago is already 10 years out of date. So if you look, you'll see that we get to 1.5 degrees on all of these scenarios out here, about 2035. Well, as was pointed out earlier, we're already there in 2025, so we're there 10 years earlier. And these 2 low scenarios here, well, I'll come on to the detail of that in a moment. So the critical thing is that we are warming faster than even 5 years ago was being projected. And you have to ask yourself the question for a moment, just think about this. if after 4 years, these IPCC projections are already 10 years out of date, how much confidence does that inspire in policies that are based upon these statistics? And there's no reason to suppose that this isn't going to change, because when you go through the history of the IPCC reports, you see these sorts of changes from one to the next, because the science is unfolding very, very rapidly, and we are learning lots that we didn't know previously. So this is not an unusual experience to find these sorts of changes from one to the next. And one of the areas where there's been an equally dramatic change is in projections about sea level rise. But the thing is that even in the most benign scenarios, the temperature continues to increase for 10 to 20 years after peak emissions, before they start declining. And note here that we're talking about the increase declining. We're still well above pre-industrial. The impacts of warming, of global warming, do not stop when it stops increasing. So in the bottom scenario, the light blue one, the 1.9, emissions were assumed to peak below 40 gigatons of carbon dioxide a year in 2020, and net zero was going to be achieved by 2055. Well, they didn't peak in 2020. They've already passed 40 gigatons and still rising, and global net zero by 2055, and that's only 30 years away, looks to me at least to be wholly implausible. And the other reasonable looking scenario that might save us from Kukulki has emissions peaking around 40 gigatons in the early 2020s, with net zero in the mid-2070s. Well, they didn't peak then, and as I say, they're still on a rising trend. And while net zero by 2070 is more credible than by 2055, it's still a considerable stretch. So, adjusting for the fact that we've got this already evident delay in the realization of these numbers, even the two most benign scenarios here are taking us very close to danger territory. And the top three are well into it. The yellow line in the middle, the third one, is the one that most people think, or many of the experts think, is the most likely trajectory that we'll follow. Now that one assumes that emissions peak at about 10% above their current level by mid-century and then begin to reduce. But the chart, if you adjust it for this time issue, shows that that takes us to well above 3 degrees centigrade of warming by 2100. And the BAU scenario, the business as usual scenario, well, you're well over 5 degrees. So to make the likelihood of Kukulki vanishingly small, we have to significantly bring forward the time when surface temperatures are out of the Kukulki danger zone. But even the IPCC that presents an optimistically biased analysis, and I won't go into the technical details, but there are some of the assumptions behind the preparation of these charts, of this chart, are on the optimistic side. It doesn't offer any plausible means of doing this based solely on reducing emissions and removing past emissions from the atmosphere. Well, to me, that means that the interventions to manage the climate are a necessity. There's no two ways about it. We have to include cooling in the policy mix. So that's my story. I just want to add two final remarks. First, it's been mentioned here about some of the ethical questions. If you're concerned that climate interventions of this sort are interfering with nature, despite the fact that we've been interfering with nature for years, all I can say is, get over it. 8 billion humans have already and continue to interfere with nature, and it is what's brought us to where we are today. And if you want us to stop that interference, the only option that you really have is a very drastic cull of the human population. Take it back to where it was in 1800, back down to 1 billion. Okay? That solved the problem. Anybody, hands up for volunteers? Otherwise, we just have to get used to the idea that the Anthropocene means that we now have a permanent responsibility to manage the climate system. So let me just leave you with some images, courtesy of ChatGPT. when I asked it to visualize Kakorki, the collapse of civilization as we know it. Well, that's the potential harm. Now, it's for you to decide, and I think that this was a point that Oliver made, and I totally agree. It's for people to decide, what's important here and what their priorities are. But if you decide that that's really undesirable, and ask yourselves whether you're confident that the existing climate policy that is totally and exclusively focused on net zero emissions makes the likelihood of that outcome sufficiently implausible, that's the question you have to ask yourself. If it doesn't, then you've answered the question that's been put to us this evening. And the purposeful interventions to manage the climate are a necessity. So I hope you recognise, I think that's Hugh Hunt sitting on that chair. You might recognise the location. I thought that was very impressive of ChatGPT to be able to do that. Thank you very much.
No, get up onto the stage. You don't have to stand up, please. Though, if you want to stretch, I don't have a problem with it. I thought those were lovely presentations. I actually want to ask Hugh, Alicia talked a little bit about sulfur emissions. Can you just fill us in on where the science of sulfur emissions from shipping has got to at the moment?
So sulfur emissions, well, as Alicia was saying, around 2020, there was a sudden drop in sulfur emissions. Sulfur does a couple of things. If it gets high into the stratosphere, it causes reflection of sunlight in the high stratosphere. But sulfur also is pivotal in nucleating clouds, so that and you can look up ship tracks. If you Google ship tracks, you will see that you, perhaps less now, but you could see where ships travelled because the sulfur was nucleating clouds. I think it's, you mentioned James Hansen's view that the reduction in sulfur was not only causing less reflectivity, but also, historically, the modelling that the IPCC was relying on hadn't included the effect of the aerosols that were there. So not only are we in a place now where there's less reflectivity, but the way we thought we were going didn't take into account the presence of the aerosols. So it's a kind of double whammy of the aerosols.
In fact, I think Hansen's position is that it didn't sufficiently. It does. I mean, there are cloud aerosol interactions in the models. That's why even in the non-Hansen models, you see an acceleration in the warming, but you don't see. But Hansen just sees a lot more of it. I think the thing that's really striking to me, and unless you were talking about this, there are now good estimates of how much that's changed the climate, and it's not a whole hell of a lot. It's less than 0.1 degrees Celsius. But at the same time, that was one set of regulations put out by one body without really anyone except me and a few other people who read the same things saying, hang on, I'm not saying you shouldn't regulate sulfur, because sulfur, and the model suggests that sulfur from ships in the middle of the ocean still gets to people on shore, and it still harms their lungs, and they still die. No one's, I think, saying that you shouldn't try and save. Their numbers are, I think, in the sort of like 50 to 70,000 lives by these controls. But to do it without even really thinking about the climate effects was really extraordinary, especially since the late, great Paul Crutzen actually warned us about this. In 2006, he said, you've got a trade-off. If you start saving people's lives by reducing sulfur down at the bottom of the atmosphere, you immediately, you owe it to yourself to think about what about putting some sulfur into the top of the atmosphere to get the cooling effect without the killing effect. So I was intrigued, though, Alicia, what you were saying. What's the actual breakdown between people who pay more for low sulfur fuels and people who put on scrubbers and use high sulfur fuels?
My understanding, but this is a little out of date now, is that there's something like 10% of ships in the world have scrubbers. And so essentially the decision that ship owners were facing was that it was basically like an OPEX or like operating expense or capital expense decision. So either you pay for more expensive fuel with lower sulfur content, but you don't have to install any sort of equipment, or you pay for the equipment and there's this big upfront cost of about $2 million, but then you can burn cheaper fuel. And so it just depends on, well, how much fuel are you burning, right, to be able to basically compare which option makes sense. So all of the big ships, very roughly speaking, like all the massive container ships, they went for the scrubber approach because they burn the most fuel. But a lot of the smaller ships didn't go for that approach because it didn't quite make sense to them.
Cool. I wonder if either of you had any questions of Robert about Kakalki. Kakalki?
Kakalki, I call it.
I have some, but I don't want to just run off at the mouth myself. Were there any things about Robert's presentation that struck you as particularly alarming or indeed wrong?
But so, Robert, you were saying 3 degrees is Kakalki?
Yes, I think that, I mean, I'm no expert in these things. I take, like everybody else, I stand on the shoulders of giants here and cherry pick the bits that I like from the IPCC reports. But I think that the evidence that is presented there, and actually Hansen again is another a source looking at, as he does recently in the paleo record, that when you get to temperature increases of that sort of order, you may remember the big furore about the so-called burning embers diagram that was presented in the IPCC reports earlier on. I think it was the first one was in the third one, I think it was, where they had this little chart that had rising temperatures and described what the consequences were in various different domains, in agriculture, in healthcare, in marine environments, and so on and so forth, how they were affected. And as you went up the columns, they got redder and redder and redder to indicate the sort of level of danger. And this caused a lot of upset because it was considered to be highly tendentious. But in any event, I think the view is that as temperatures get, certainly as they begin to rise above 2 degrees, things start changing rapidly. And one of the problems we need to remember here, and I don't think I used the word system much in what I just said, but this is a climate system, and we are all parts of the climate system. The climate system encompasses everything that happens on the planet, and it's a complete web of interconnected links. And you pull this bit and that bit changes, and you don't know how these connections work. And it's an incredibly fiendishly complex system that is constantly developing and changing in response to various influences and stimuli that are imposed upon it. And so this makes it absolutely impossible to accurately predict. You can't really, create a model and say, this is how it will be. So there's a huge amount of uncertainty in all of the assessments of exactly what will happen in the future. And one needs to remember that. We get all these charts up here and all these lines that, some a bit squiggly or whatever, and we kind of look at the numbers and think, oh, well, that's the number. But actually, there's a vast amount of uncertainty in these numbers. And the points that have just been made about Jim Hansen and his views about aerosols and so on and so forth. If the chart that I presented to you just a moment ago reflected James Hansen's recent views about the value of what's called the equilibrium climate sensitivity, the amount by which surface temperature would increase if carbon dioxide doubled, all of those lines would go way up. They would tip up dramatically. Now, that doesn't change what's going to happen. It just means that our understanding is not yet complete, and there's still a lot of uncertainty about these things. So, yes, I am of the view, based on what I've read, that certainly at 3 degrees of warming, we would be in great difficulty. I think you would definitely be talking about a radically different world, because our food supply, our global economy, the hydrological cycle would all be really, really seriously disrupted.
Okay, I'm going to, in just a moment, start thinking up your wise, trenchant, and searching questions, because I'm going to come to you in just a moment. I'm just going to pull back a little bit. I was talking to on Robert's point on two dimensions. Not the one about uncertainty, and this is actually just a sort of like inversion of something we know from everyday lives. But I was talking with a friend who. Politically active friend who thinks a lot about climate just last night. He pointed out to me in a way that I think was true and something I never really thought about before. In fact, the fact that the world will be 2 degrees hotter than pre-industrial in 2050 is actually one of the few certainties we have about the world. The uncertainties are not that great compared to the inertia of the system, both the emitting system and the response of the system. That really is, something you can know, something you can pretty much take to the bank. Even if we were to go full on for solar geoengineering, it wouldn't have much effect before 2050. So that's, I think, an interesting counterargument. The other one is, obviously, solar geoengineering is not the only, obviously climate change is not the only route to Kokorki. There's a very well-established one through thermonuclear war. Why concentrate on climate change? And also, what is your argument for thinking that attempting climate intervention might not lower the Kokorki risk from climate change, but potentially increase it from nuclear war?
It may do. I haven't thought about that. It's quite possibly it will be the case. But I think that the issue for me is that the risks of widespread societal collapse are all driven by the increase in global surface temperatures, which affect all of the systems on which our lives depend. And one way or another, because over the last 40 years we have been so pathetic at reducing emissions and bringing those down, we've now created a situation where, frankly, I don't think if we want to control the surface temperature, we have to use direct cooling, because one of the features of carbon dioxide, which is the main greenhouse gas, is that its effect in the atmosphere is very attenuated. It arises. The way it works is that if you put a certain amount of carbon dioxide in the atmosphere, about a third of its surface temperature impact arises in the first 10 years. The next third arises over a century. And the last third arises over thousands of years. So the problem that you have with trying to solve the climate change issue by removing carbon dioxide is simply one of scale. You have to take out so much, so quickly, that it's simply infeasible. I mean, one of the things that, again, we're talking a lot about James Hansen, who's hopefully that most of you will be familiar with. But in one of his recent papers, he pointed out that the Earth's reflexivity, its albedo, had changed by 1.7 watts per square meter in the last decade or so. Now, what's interesting about that, and that was because of changes in clouds, changes in these aerosols that we've been talking about primarily, and a little bit to do with the changes in the polar ice caps. But what was interesting about this was he then pointed out that 1.7 watts per square meter was the equivalent of 120 parts per million of atmospheric carbon dioxide. Now that is, we're increasing, with all our emissions, we're increasing parts per million by 1 or 2 parts, 3 parts per million per annum. In 10 years, the albedo effect is equivalent to actually almost a century of the equivalent carbon dioxide effect. So there's a real imbalance in their impacts. And these are really challenging issues to sort out.
Okay, questions?
And can I just ask, just mindful of time, so questions, if we can keep them short, and answers,
Short.
Can we keep the answer short? Because I'd like to ensure that as many people as possible are able to participate in the discussion.
And if
Oliver.
you wouldn't mind, if you could say who you are when you ask a question, that helps us. But I ask people to think up some questions. Who has thought up some interesting questions?
Can I also suggest if there's a female who'd like to ask the first question, right? And it was Barony Bryan's Worthington that told me actually that the top tip of this, it changes the dynamics of the room. So do we have any females who would like to offer the first question? That's a bit of an ask, isn't it? Great. Louise.
Hi, I'm Louise. I'm at the British Antarctic Survey. Thanks for the nice presentations. I was just curious about the cost of taking the carbon out of the shipping. So how much carbon does it take to remove, or what's the costs associated, both in terms of dollars or whatnot, but also in terms of carbon for the actual carbon removal?
The cost on the ship.
Yeah, for sure.
That's really for you.
Yeah, so our focus is to get our cost per ton of CO2 captured to be about $150 per ton. So that's what we're working towards. We're not there yet, but we have a roadmap to get there. So that's, yeah, and that kind of includes the equipment cost as well as the operating expenses for swapping out our containerized system.
Great. Up there. Yes, thank you.
Hi, I'm Rebecca Sellick. I'm a railway engineer. My interest is in a wider than that cost. How do we do the relative cost of all these things in terms of carbon, in terms of energy, and over what time frame?
I'm sorry, could you be a bit more precise? I didn't fully understand the question.
Lots of decisions to make about what mode to adopt and how much prevention and how much cure and the mix of policies around here, and how should we be measuring, what criteria should we be using, and over how long a time frame to say, well, we should do some of this and some of that and some more of the other. You know, is there a way of framing that so in terms that the governments can understand where there should be investment and whether there should be more or less investment, the way of prioritising?
Okay, I was suspecting that you might want to answer
Well,
that.
I just feel as if we're in the uncertainty picture. We don't quite know what it is that's going to be needed in the next 10, 20, 30 years. So we should be researching everything we possibly can and figuring out, having a portfolio of ideas. Because I don't think we really know what in the next 10, 20, 30 years' time are going to be the most important things that we will have done in the previous 30 years. We do need to get off fossil fuels. We do need to get greenhouse gases out of the atmosphere, and we do need to get on with albedo enhancement. But all of those things have got lots of methodologies attached to them. Which ones are going to be the most important? I don't think we know right now.
Can I say?
Yes.
I just want to add, I think that one of the critical points, and I want to totally agree with you, that all of these things are going to be important. And we don't know how the cost profiles are going to kind of work out. The current thinking is, that broadly speaking, that albedo enhancement, you can deliver a surface temperature impact massively cheaper than you can with either reducing emissions or with carbon dioxide removal. And but the critical point here is that we need to start doing not just research, but we need to start doing practical research, actually getting engineers out there doing stuff, initially at small scale, but learning by doing. Because the one thing we know is that humans have been learning by doing for millennia. You know, building bridges is dangerous. Building aircraft, they fall out the sky. But we are really good at developing these technologies and making them safe. And there is no reason to suppose that any of the technologies we're talking
Aren't we
about
the
here...
people who just developed a technology for ripping up ancient carbon and poisoning the planet with it? Are we really good at being safe?
We are good at being safe, yes. Well, we make mistakes and things go wrong, but we do have
You just said we've made woeful failures for 40 years. So it doesn't sound like, it sounds like we're pretty good at making systematic mistakes.
No, wait a minute. We're talking cross purposes here.
I think I'm just deliberately trying to undermine you. I don't think it's
It's easily done. It's easily done. But I'm talking about our capacity to build engineering solutions and to make things work safely and cost effectively. What you're talking about is the political will and the political process of deploying them and using them. Now, it is quite true.
Okay. That's a reasonable point. I would just add to your question that something we always have to remember in this is that the costs and the benefits will not be evenly distributed and they will not fall on the same people. And that's always the problem with this sort of discussion.
But now, Oliver, can I just say, on the cost side, Alicia, did you say $150 a tonne?
Mm-hmm.
Okay, now if I divide by 1,000, that's 150, 15 cents a kilogram. And I can't buy orange juice for 15 cents a kilogram. How come we're expecting this to be so cheap? Isn't this an important enough problem? We should be willing to pay a lot more for it.
Yeah, and I think maybe the question I'll add as well to that question is that, like, I think it's helpful that there is starting to be this convergence around, well, how much should it cost to reduce CO2 emissions, to capture it like we do, or to do carbon removal. And a lot of people work towards this number of $100 per ton. That's kind of the golden target. We're now saying 150 because I don't think anyone believes 100 is really that possible.
That's so cheap.
Which, yeah, I guess it's all relative, but I think it's helpful that you have things like the emissions trading scheme in the EU that actually is pricing this. So ship owners don't capture CO2 on ships because they want to. It's because they have to comply with regulation, or they're going to face a penalty, or they're going to have to pay that carbon tax, so they'd rather pay us if it's cheaper, right? And I guess I'm just wondering, like, has anyone quantified the cost or the benefits of, like, reflectivity or temperature change, or, like, who's paying for this, and how are we measuring it? Because I think it's taken time to get to this carbon pricing mechanism, and have we priced any of the other impacts that we've been talking about today?
Okay, there was a question up there. Yes, you.
A very brief comment and a question. Great presentations that make a clear case that climate intervention is a necessity, but don't actually disprove it being a distraction, because it's clearly part of the strategy of the fossil fuel industry is to use it as a distraction. But my question is, what about nature in this? Because some of the techniques presented reduce CO2, and so they reduce ocean acidification, but some of them don't, and marine ecosystems will collapse with acidification, even if the temperatures don't rise. Mm-hmm. So how do you factor in the ecosystem function aspect alongside temperature?
I'd like to take that one, actually, because it's something I've thought about a little bit. And I think it's one of those cases when what seems like a bug is in fact a feature, and this goes back to the 2006 paper by Paul Crutzen that I was talking about earlier. The fact that solar geoengineering doesn't do anything about ocean acidification is a strong argument for what I think everyone who works on solar geoengineering believes, which is that you have to work on emissions reduction as well. You don't want to end up in a permanent situation where the offset between the experienced climate and the potential climate due to the greenhouse gases is really high. And so ocean acidification is a good, strong reason for reducing emissions as such. And so I think that if solar geoengineering cured ocean emissions, then ocean acidification rather, then I think you'll possibly see a world where people really didn't care about going on emitting and would come up against something else. So it's a little bit like keep on reducing emissions, or the sea urchin gets it, is not a great moral position, but it's one that I think we're kind of in. Andrew, did you have a question? I saw your hand up earlier.
Yeah, my name's Andrew Lockley and I'm late. So I wanted to ask the panel, when and by whom do they think solar geoengineering will first be done at scale? And is this going to be after or approximately at the same time as the collapse of civilization? Or will we get organised to do it beforehand?
Alicia, do you think it's fair to ask you that question since
Sure.
you don't think about solar geoengineering very much? But go ahead.
So I think there are already people working on this. There's an example, and I think I won't name them directly, but there's startups in the Silicon Valley that are funded by venture capitalists and angel investors that are releasing sulfur into the atmosphere. Or they're kind of going rogue, if you will, and doing their own thing. And I think they have reasons to do that that they could tell you about. But so I think like it's already happening, I guess, is the first answer. And I think what makes me nervous about that is that if people start to go rogue, if you will, then I think there might be even more backlash, and it might be more difficult to be conducting research in the ways that might generate more consensus and potentially have greater impact upcoming. So I guess that's kind of, my quick comment on that is that it's already happening, but I don't know. And if we don't do it in a coordinated, careful way, then I think people will just kind of keep going rogue, because people want to act, people want to get involved. I don't know if you have other.
Robert.
Yeah, this is a really interesting question that is something I've been thinking about since I got involved in this 15 years ago. I've always thought that the idea of a green finger, a sort of malevolent Silicon Valley billionaire doing this in a rogue state was improbable, implausible. And I wonder now whether I got that right. I still think it is. And let me explain why. There is no doubt.
Briefly, because you also need to say who will do it, and you need to say a date, and you need to say it within the next 70 seconds.
Okay, it will not happen other than at small scale, because to do it with enduring climate effect is not within the power of anyone other than governments globally working together. So if it is done, it'll be done as in a rogue way, and it'll be stopped. It won't endure. It will be stopped.
Hugh.
Well, Andrew talked about at scale. I think that Robert's statement about we learn by doing, we'll start with doing things at a small scale and it'll grow up. And will we get to the point where it's at scale? Eventually, yes, but I don't think it's going to happen very quickly.
Okay, I think that and I'll come to Sean in a moment, but I'm going to answer Andrew's question as well. 2042, I think the most likely is that there's a real ungageable possibility that it just doesn't happen for various other reasons.
Agreed.
But I would say 2042 by a coalition involving at least one major Indian Ocean state and supported by technologists from outside that area, and it will get to 5 megatons of sulfur dioxide per year within 10 years of that starting date. So that's my prediction, since you were so kind as to ask. Sean.
I'm just mindful of time, Oliver, so we need to be out of here, literally all out by 8 o'clock. So I was going to take the privilege, if you don't mind, Oliver, of asking you the final question. And that is, we've talked about climate intervention, a distraction or a necessity. Is that the big question? Or is the bigger question that should we be talking more about just climate intervention, period? In other words, how well known is climate intervention in global society today? And is that the bigger issue, the fact that we're just not talking about it?
Well, since you asked me directly and since you told me that we have to get out quickly, I'd say yes, that is the bigger issue. But the other thing is, it's very hard to do because you can only really think seriously about these, especially about the solar climate interventions, if, you'll pardon me putting it this so bluntly, if you appreciate how deep the shit that we're in is. And people aren't willing to appreciate that. They are willing to sort of think that it may be the case, but they also think that, if this government did a bit more, whatever. And there's a very steep discontinuity, I think, between being stupid and talking about the end of the world in 2035 and being, we'll probably muddle through. And I think a really clear-eyed sense of what the current climate situation is will bring with it a sense of what climate interventions can do. But there is no incentive on anyone to actually provide that clear-eyed view of climate, because people want to tell you either that they're sorting it out, and many people are making valiant efforts in that direction, or that it's not a problem, or that we're all doomed, and we're not getting the sort of discussion of this that the subject deserves.
Great.
That would be my answer to your question.
So, could I ask us to please thank the most amazing panel for today?
Thank you. Thank you for coming.
And they will be available outside for further questions. I was going to, for those of you who are interested in furthering the conversation, the first thing is, for those of you who might be interested and are able to travel, Oliver and the organisation of the Degrees Initiative are hosting an incredible conference in Cape Town. That's the week commencing the 12th of May of this year. It's the Degrees Global Forum. I would encourage you to investigate that. We are very excited about that. And then the following month in June, there is a further gathering here in Cambridge, 26th to 28th of June. Please look at both of these if you would like to continue getting involved in the conversation. Thank you again for the panel. Thank you.